Hello everyone. So this is math test 2 review sheet and I'm going to show you how to solve these problems which are going to be on the test. Very similar problems. So remember the sections that are going to be on the test are 2.7, 2.8, 2 point modeling, then 3.1, 3.2, 3.3, 3.4, 3.5, and then 3.6 and 4.1 and 4.2. Now, section 2.7 dealt with a combination of functions. If we are given two functions, how can we combine them? There are several ways that we saw they can be combined. One is that they can be added. So if you are given a function f of x and g of x, then to find the function f plus g of x, this will be the same as f of x plus g of x. And you remember how to find the domain. Basically, the domain of f plus g, this function, will be the intersection of the domains of f of x and g of x. Then same thing goes with for subtraction. So instead of rewriting a new whole equation or a whole expression like this, we can just put a negative sign over here. For plus minus, this is how it goes. So now there is another combination could be that f g, what this has mean, f multiplied by g of x, because there is no symbol here, no sign or symbol between f and g, means f and g are being multiplied. So this will be f of x times g of x. It is not composition. This is some students got it incorrect in the homework. They thought this is f composed with g, which is it is not. I think in the first test some students made that mistake. But then another way to combine was f divide them, f over g of x. So that will be f of x over g of x. Now to find the domain of these three functions, first three, the addition, subtraction, and multiplication. This is just the common domain of f and g. Now to find the domain of f over g, it will be the common domain, but then something extra has to be checked, which is that the g function, which is coming in the denominator, should not be 0. So we have to take away or throw away the zeros of the function g. Another way to combine was to find the composition. So f composed with g. So if you see this little circle between f and g, that means composition. So that will mean f of g of x. So make sure that you understand this. Now, the example that I gave here from that section 2.7, and by the way, 2.58, we combine 2.7 and 2.8. So 2.8 talks about the inverse functions, or how to find the inverse of a function, and what is the relation between the function and the inverse function, graphs. So here, let's look at the example. So you are given two functions, f and g, and you have to find and simplify this quantity, and then later on we have to find the inverse of the function x. Now this does not mean now that you will be given exactly similar type of functions and similar type of expressions here. No, that what I mean is that is not what is meant by the review sheet. The review sheet means it gives you concept. It gives you that there will be a question where you have to find or evaluate the combination of functions at a certain value and then interpret the results. So, and the function could be very different. These are both rational functions, we can say, or you can think of this as a rational function and you can think of this as a polynomial with rational coefficients. You can think of it like that, or you can think of it like a rational function, because remember 3 is a rational number. And so now I could give you a square root function, I could give you cube root function, I could give you a quadratic function, any type of function. I can give you the type of function that you have seen already. So you should know how to evaluate each of them and then go from there. So let's look at this first problem now. The first thing we will do is, what will be f times g of 4? So f times g of 4 means, by definition, f of 4 times g of 4. So what is f of 4? So f of 4 will be equal to, I will plug 4 in the function f, 4 minus 1 over 8 minus 5. So I get 3 over 3, which is equal to 1. Now I find g of 4. So I will plug in 4 for x and g. So I get 8 minus 1 over 3, or 7 over 3. So that f g of 4 will be equal to 1 into 7 over 3, or 7 over 3. So this is our numerator for the quantity. The next thing we do is find the value of the composition. Okay, so this we will need this later. So now I look at what is the bottom here. So we want to find g of f, g composed with f of 4, which means g of f of 4. Now f of 4 we have already evaluated in this part, or in this portion of the solution. So I will not evaluate it again. So I will just use it. So which means is equal to g of 1. Now I will take 1 and plug it in for x and g. So this will give me 2 over 3 minus 1, if I use this thing, 2 over 3 minus 1 over 3, or if I use this one, it gives me 2 minus 1 over 3, or 1 over 3. Okay, so now I have to do the division, because I have to find the quotient. So then now top fg4 over g composed with f of 4 will be equal to, so the top is 7 over 3 and the bottom is 1 over 3. So we end up getting 7 over 3 times 3 over 1, or 7. So this quantity is 7. Now, as I said, don't assume that you'll get exactly a similar question where you will have a product of the function and then a composition. I could have both compositions at the top or in the bottom. I could have one of them as a sum or difference or quotient. So that's why you need to practice the different similar type of problems on the whole final exams. Okay, the next one is we have to find the inverse function of the function f. So if you recall, there are 4 steps to remember. Find the inverse function. So the first thing we do is the first step is that we write the we change the f of x into y. Okay, the first step is instead of f of x, we write y. So we have our function f of x up there. So I will replace the f of x by y, and everything else on the right hand side will remain as it is. The next step is to switch x and y. Now this step, some people do it at the end, some people do it at the beginning. It's your choice, but somewhere you have to switch. That's what you have to remember. So if you didn't switch, so the sequence goes like this. So you set f of x, you replace it by y. So your equation is y is equal to something, which uses x. So at this time, if you switch x and y, then your goal will be to find the new y. And then that will be your, that will be your function f inverse of x, the new y. If you didn't switch and you went with this given equation which I have, then instead of y, you will have to find the x. Once you found the x, then you will have to switch x and y, and then that y will be your inverse function. So I can show you in both ways. So first we switch. So I get x equals y minus 1 over 2y minus 5. And the next step is to do some algebra and get y by itself. So what do? I cross multiply. Or you can say I multiply by this denominator on both sides. The third step is 2y minus 5 times x equals y minus 1. So remember, we have to find the y. So the next step is, now it's just basically algebra. I won't say this next step, but just we want to find the y. That's the goal. So let's find the y. So I get distribute on the left hand side. So I get 2xy minus 5x equals y minus 1. Now since we want to find the y, we will collect the y terms with y on one side and everything which does not have y on the other side. So I will subtract y from both sides. You can see it will cancel this y, and we will see a y appearing on the left hand side. And then also we will add 5x. So 5x will disappear from here and it will show up on the right hand side. So my expression will look like 2xy minus y equals 5x minus 1. Now we will factor this y from here, and inside we get 2x minus 1, and on the right hand side 5x minus 1. So now we divide by 2x minus 1, so y will be equal to 5x minus 1 over 2x minus 1, and this is your inverse function. Now let me show you the other way. So let's say we do not switch. So this was method 1, and now this is method 2. So y is equal to x minus 1 over 2x minus 5. So remember, in the method 1, we switched x and y at this step. And now we are going to not switch, but we are going to find x. So we start the same way. We will multiply both sides. by 2x minus 5, or you can say we cross multiply. We get 2x minus 5 into y is equal to x minus 1. Now distribute on the left hand side. Get the x terms on one side, or get all the terms which have x in them on one side. So I get 2xy minus x. And then all the other terms, all the terms which do not have x in them, we move them to the other side. So I will add 5y. So the 5y from here will go away. And then we will have 5y on the right. So I get 5y minus 1. On the left hand side, factor out the x. We get 2y minus 1. And on the right side, we have a 5y minus 1. Now x will be equal to 5y minus 1 over 2y minus 1. And now we switch x and y. So we get y equals 5x minus 1 over 2x minus 1, which is your f inverse of x. So see, both ways we get the same answer. So you have to just focus on learning one of these ways. Okay, let's now look at the second example. So this is for modeling, and for this it's very important that you draw a figure. Almost for every modeling problem there should be a figure associated with that. Very few times it will be that you don't need a figure. Sometimes the figure will be given to you, so then you don't have to draw it, but basically most of the time you need to draw a figure. So here we have a situation that we have a wire. Okay, so let's say the wire which is 6 centimeters long, and we cut a piece. Just randomly we cut a piece without measuring. So the total length is 6 centimeter. If someone cuts a piece from here and say this is of length x, then what will be the length of this remaining? So let's say this is A, this is B, and this point is C. So the length of CB is x, and the length of AC will be 6 minus x. Okay, now the question is saying that the piece that is x centimeter long is bent into the shape of a circle, and the piece that is 6 minus x centimeter long is bent into the shape of a square. So the piece which is x, we are bending it to make a circle. So remember, you can say this and this. So we kind of bend it, it becomes a circle. And you can see this will be a small circle because this is the whole thing that we use as to make that circle. So this length x, where has it gone in the circle? Where is it? It becomes the circumference of the circle. Okay, and what is the formula for the circumference of a circle? Circumference is equal to 2 pi r. So we say x is equal to 2 pi r. So from here I can get my r in terms of x. So r will be equal to x over 2 pi. Because remember, eventually we have to write the formula for the area of the circle, and that requires r, and we don't have the r at this time, and we don't know what the r will be, but we can find it in terms of x. That's what we have to do. The second piece, which is 6 minus x centimeters, that is bent into a square. So where does this whole piece go? we have a square, right? What is the length of each side? Because if I know the length of each side of the square, I can easily write if I know the length of one side of the square, I can write the formula for the area of the square. So a big mistake that students do, they take this one side to be 6 minus x, which is not correct. Because your total length is 6 minus x, you will have to take this wire, maybe let's say bend it from here. So this piece, let me redraw this. This is what you are going to do. You have the length x, 6 minus x, so from here to here. So let's say I bend it over here. So the piece goes like this, and the rest of the piece, which was here, it now hangs like this because I bent the row. Now I bent again here. So this piece goes like that. And then I bend again and like that, right? Now I bend again from here, and this piece closes the loop and it makes a square. So this whole length, which we call the perimeter of the square, that is what we have as 6x. So let's say the one side of the square, let's say, is A. Then what is the perimeter? Perimeter will be 4A. But what do we know from now here? That 4A is equal to 6 minus x, which means A is equal to 6 minus x over 4. Okay, now you know your A, you know your R, so we should be able to write our formula. Maybe you can do it like this here. You can call this A1. Now formula for A1 means formula for this area of a circle is pi r square. So pi r square, which means pi into x over 2 pi whole square. And for this square, I'm going to call it A2, so it will be little a whole square. But what is little a? Little a is 6 minus x over 4 whole square. So now I can write the sum of the two squares. So the area will be equal to A1 plus A2. So it will be pi times, so quantity squared will give me x squared over 4 pi squared plus 6 minus x over 4 whole squared. So this is the total area, but we should now simplify it. So you can see this pi will cancel one of the pi's. So we are left with x squared over 4 pi plus, we can expand this to get 36 minus 12x plus x squared over 16. And this will be the formula for the area of the two shapes. Okay, I'll stop here and then I'll do 2 more problems in the next video.